Close your eyes. Imagine a place where nothing exists. Complete darkness. Now imagine a tiny little point in that nothing. Within this point is everything that will ever exist. All the matter and energy there will ever be. Now, imagine this point explodes out in all directions. 13.7 billion years later, becoming the universe that we know today. This is the Big Bang Theory. Now, I'm not a scientist. I'm just a normal person who really likes science. I've read a couple of Stephen Hawking books. I got a couple of audio books that I can nerd out to while I'm driving. I watch any documentary on the universe that I can. So, I'm no expert, but I have done some research. I want to give you two pieces of evidence to support the Big Bang Theory. But first, we need to go through our understanding of the universe. According to Stephen Hawking's A Briefer History of Time, in the 4th century BC, the Greeks observed the moon, the sun, 5 planets, and the stars. And they gave us this geocentric model of the universe, where the Earth was in the center and everything orbited around the Earth. Now, this belief was held for about 1,000 years until the 1600s, when Galileo proved that the sun was at the center of the universe. Then in the late 1600s, Isaac Newton gave us the laws of gravity. And then coming up to more modern times, Albert Einstein came into the picture. And his calculations pointed to a beginning of the universe, and he also gave us his theory of general relativity. But then finally, in 1919, Edwin Hubble changed our entire picture of the universe. Before he looked through this newly completed 100-inch telescope, our view of the universe was that the Milky Way was everything. Every star that we saw was part of this Milky Way universe. Our sun was one of those stars, orbited by 8 planets. And as a side note, Pluto had not been discovered yet, so it couldn't get kicked out of the Planet Club. But after he looked through this 100-inch telescope, he saw that a lot of the things that we thought were stars were actually other galaxies, and there were millions of them. So our universe got a whole lot bigger that day. But before we go on, we need to look at what a theory is. So according to the dictionary, a theory is a proposed explanation whose status is still conjectural. So in other words, it's a statement that can describe something, but it's not been proven yet. So what happened next gave us the first evidence for the Big Bang Theory. So after years of observing through his telescope, Hubble showed that the universe was actually expanding. According to Stephen Hawking's A Briefer History of Time, he showed that by the Doppler effect, the light coming from these distant galaxies was slightly red shifted, which meant that the galaxies were expanding or going away from us. So in case you're unfamiliar with the Doppler effect, here it is. As the sound gets closer to us, the sound waves get shorter and the pitch goes higher. As it goes away from us, the sound waves get bigger and the pitch goes down. Well, it's the same with light. First, you need to understand why we see different colors. They're different colors because they're different wavelengths. Red light has a bigger wavelength and blue light has a shorter wavelength. So when we're looking at something that's moving away from us, the light from that thing moving away from us is bigger, so it has a slight red shift. Whereas if it's moving closer to us, it has a slightly blue shift. So observing these galaxies moving away from us certainly helped to support the Big Bang Theory, but more was needed. The mathematics showed that from this explosion of the Big Bang, there should be a leftover cosmic radiation throughout the universe. It should be spread evenly throughout it. So the next bit of evidence to support the Big Bang Theory is the cosmic background radiation. This is a difficult topic to understand. What you need to know is that our visible light that we see is only part of the full spectrum of light that's out there. You've got radio waves, like when you listen to your radio, that are really big. Microwaves, which are a little bit smaller, like from your microwave. Infrared rays, and then you've got the visible light spectrum, and then it goes to ultraviolet and X-rays, like when you get an X-ray, and gamma rays. So those continually get smaller. So it's kind of like the math showed that there should be this explosion throughout the universe and this leftover radiation. And it's not unlike a nuclear explosion where the radiation spreads out. So according to Joseph Silk's cosmology, back to the beginning, 2 scientists found this background radiation on accident with their radio telescope. Now news spread pretty quickly of this, and eventually these 2 scientists won the Nobel Prize for their discovery. And today we actually have satellites that orbit the Earth that actually see this background radiation. And this just shows kind of an even temperature throughout what these satellites have observed. So, I know the Big Bang Theory is controversial, but it is accepted by mainstream science today. We went through the history of our understanding of the universe, and we looked at 2 pieces of evidence to support the Big Bang Theory. The Big Bang Theory doesn't really tell us what happened before the universe started, and it doesn't tell us what will happen in the future. Now just look how little we knew 2,500 years ago. Imagine what we'll know in 100 years, or even 1,000 years. Thank you.